Hi everyone, and welcome to today's lesson on the structure and formulae of alkenes. Okay, so have a look at the learning objectives that are at the top. All right, so we're going to be describing alkenes and their function. We're going to be able to name the first 5 alkenes and give them molecular and structural formulae. We're going to compare alkanes with alkenes, okay, and complete GCSE past paper questions on the topic. So if you're writing this all down, I suggest you keep all of your GCSE chemistry notes together, okay? So if you are writing it down, we'll kind of do this as a regular lesson, and I'll suggest times of which you need to write down some key points. If you're not, maybe you're watching this on your phone, that's absolutely fine as well, because you can still take part in the activities. Okay, so if you're writing this down, I suggest you write down the title, which is Structure and Formula of Alkenes, and the key words. Okay, so you might have come across this before in a different lesson, but I think it's a really, really nice question to see how much you remember. The question is, what can you see that is a similarity or a difference between these 2 hydrocarbons? So this is a key word from the topic. Okay, hopefully you remember that hydrocarbons means a compound containing hydrogen and carbon only. At GCSE, you just need to know about the alkanes and the alkenes when it comes to hydrocarbons. If you're going on to if you do separate science or triple science, then you will need to know a little bit more about alcohols, carboxylic acids, and those things as well. So hopefully you're looking at these 2 and thinking, right, what is similarity and difference? Surely the similarity could be, well, it's got 2 carbon atoms. Maybe it's the similarities that they both contain carbon and hydrogen only. A difference should be coming to light. A quite obvious one is this bond in between the 2 carbons. So maybe the bond could be, if you're comfortable using this terminology, we've got a single covalent bond and we've got a double covalent bond between these carbons. And this is what this is showing actually an alkane and an alkene, specifically ethane and ethene. So really well done if you've got any of those points. Don't worry if you haven't, because we're going to go into that in more detail. So in a different video, we look at alkanes. This video is all about alkenes. Okay, so alkenes, they are a member of the hydrocarbon family. They are used to make chemicals such as plastic. Okay, so we use them to form, again, if you're doing separate science, you go into a little bit more detail about polymers. Okay, so polyethylene, for example, polypropylene, and they are used as plastics. They contain a carbon-to-carbon double bond, so there is always going to be a double bond. If hydrocarbon does not contain this double bond, okay, and this is like a visual representation of it, then it is not an alkene. It must contain a carbon-to-carbon double bond. It's really, really important. And they are unsaturated, such an important key term. They are unsaturated and more reactive compared to alkanes. They're more reactive because of this double bond. Okay, it's quite easily broken, so that's why they are more reactive. Okay, let's have a quick look at calculating molecular formulas. So we say that all alkenes follow this rule, CnH2n. Okay, we say that's the general formula for an alkene. Now, what does this actually mean? Let's break this down in a little bit more detail, because sometimes it's just, learn it and accept it. The general formula for alkenes is CnH2n, but let's try and understand it as well. So for example, let's look at ethene down here. Let's look at this particular alkene. Now the number of carbon atoms is 2, okay? And the number of hydrogen atoms, if we're following this general formula, let's say Cn, n being the number of carbon atoms, let's plug 2 in there. This must mean that there's H, in terms of hydrogens, there's 2 times that n being 2. Okay, does that make sense? The number of hydrogen atoms is actually 2 times 2. Now in maths, when we have 2 numbers together, you multiply them, all right? And it's the exact same here. So it's saying for whatever number of carbon atoms you have twice as many hydrogens. That's an easier way of kind of thinking about it. Okay, so let's see if this checks out. So we've got 1, 2 carbon atoms. We've got 1, 2, 3, 4 hydrogen atoms. So we do in fact have C2H4. Now that is the molecular formula for ethene, okay? The general formula was this. I hope that's clear. let's have another practice just to make sure we understand it. So again, we've got the general formula on the screen. Let's give ourselves the molecular formula for this alkene. Let's see if we can work it out. If you want to have a go now, make sure you pause the video and see if you can give me the molecular formula of this alkene at the bottom left. Okay, so it's got 5 carbon atoms, which means it must have 10 carbon atoms because it's the general formula. Let's see if that's correct. So let's count our carbon atoms. 1, 2, 3, 4, 5. And let's count our hydrogen atoms. It doesn't matter how we count them. We've got 10 hydrogen atoms. So this now on the screen is the molecular formula. Okay, now if you can also tell me what it is, that'd be really, really impressive. Maybe you've watched the Alkene video and you remember, right, methane, ethane, propane, butane, pentane, maybe remember all of that. You can actually put it into the context of alkenes as well. So maybe remember that 5 or a 5-sided shape begins with pent, okay? And you'd be absolutely correct in saying that this molecule here is called pentene, not pentane, because it's not an alkane, but pentene. 5 because it's got 5 carbons. So really well done if you got that. Let's have a go at this. Okay, so I'd really, really recommend if you are writing any of this down on a sheet or a workbook or in revision notes, maybe you've got some little revision cards, which is fantastic. I would suggest that you follow this kind of method in terms of identifying the alkene, right? The first one being ethene, all right? The number of carbon atoms, okay? You've also got the formula here, so which is C2H4. Just remember to keep your numbers small, like subscript, okay? It could be a little bit clearer. I think it's better to keep them nice and small. And you've got the structure, all right? I think it's a good idea to have a guess, maybe, if you're not sure of what's going on in terms of the names. Okay, look back if you haven't already at the Alkene video as well to help you with the names. So we're going to start with 2, which always starts with eth, 3, prop, 4, but, 5, pent. There is no such thing as methane because we know that we need a double bond. So you can't have just one carbon. Okay, so methane doesn't actually exist. What I'm going to suggest is that you pause this video then and have a go at completing this table or writing it up in your notes before we go through the answers. Okay, we're going to go through the answers now, so hopefully you've had a go. Propene. Now, really well done if you've got the name, the number of carbon atoms and the formula correct. If you got the structure wrong, let me help you out. Maybe you did an extra line here with the hydrogen. You're thinking, what's going on? Well, so a couple of rules I would suggest when it comes to drawing the structure of alkenes. Firstly, I would suggest doing a double bond between the first 2 carbons. It doesn't have to be, all right, but I would suggest that for GCSE. It makes it a lot easier. Okay, so firstly, let's put the double bond between the first 2 carbons. Secondly, you need to think about how many bonds carbon can actually make, okay? How many bonds it can form with another atom. Carbon is in group 4 of the periodic table, all right, which means it's got 4 electrons on its outer shell. So it can only bond with 4 different things, okay? It can form 4 bonds, or to simplify it, it can have 4 lines coming off it. That's the rule, okay? No more. It cannot form any more bonds. So if you're this carbon, think, right, I need 4 lines coming off of it. 1, 2, 3, because there's 2 in that double bond, 4. If you're this carbon, again, let's count as 1, 2 in the double bond, 3, and 4. I can't have a 5th bond coming off of carbon. I just can't. Okay, it's chemistry, it just doesn't exist, it doesn't happen. And again, with this carbon, let's just check. I've got 4 lines coming off of it. I've got 4 electrons in the outer shell. 1, 2, 3, 4. Ah, perfect. Okay, so what I'd suggest if you're having a go at the others, do so and always check, pretend that you're each carbon at a time and go, right, how many lines are coming off of that one? How many lines are coming off of that one, etc. Let's go through the answers to the others. Then we've got butene, pentene, and well done if you've got hexene as well. That's fantastic. Remember the formula, or the general formula, is CnH2n. So it's got twice as many H's as C's. And I would just suggest that you watch out with the number of hydrogen atoms coming off of these ones. These are a little bit easier, but it's the ones right at the start. Really, really well done if you've got that sheet or that table of information correct. What I'd suggest is to have a go at this, okay? Again, feel free to do this in your notes or feel free to do it verbally. Drag and drop the statements to compare ethane and ethene. So this is a quick comparison between alkanes and alkenes, okay? So some different statements here, for example, relative formula mass, simple molecules. There's some different formulas on there. And there's the terms unsaturated and saturated. Okay, if you're struggling a little bit with relative formula mass, that's actually part of the quantitative chemistry topic. Okay, so you can have a guess if you're not sure, but if you know, then you know to look at the relative formula mass and the relative atomic mass of those atoms in the compound. So pause the video, and for your notes, it'd be a really good idea to put them into 3 different categories because it's going to help you with the GCSE past paper questions. Make sure you have a go because I'm going to go through the answers. So last chance to pause the video and have a go at this. Okay, so really, really well done. If you're self-assessing it, make sure you get a different colour pen and mark them as you go. Okay, ethane, the relative formula mass is 30. This is the general formula. This is its molecular formula, and we say it's saturated. For ethene, the relative formula mass is 28. This is the general formula, the molecular formula. It contains a carbon-carbon double bond, and it's unsaturated. And of course, both of them, they are simple molecules and they are hydrocarbons. All right, so really, really well done. Let's have a quick go at a couple of GCSE past paper questions just to make sure that you've understood. So I think we've just got one in this lesson because actually a lot of the questions link alkenes with polymers and plastics, which is kind of separate science only. So there's very few questions that are by themselves, but you never know, okay? So it's always good to try a question. So crude oil is used to make useful substances such as alkenes and plastics. The alkene shown is ethene. Tick the correct formula for ethene. So this is a nice one. I'm going to give you a few seconds to work it out. It's 1 mark. You might think, oh, it's only 1 mark, but actually 1 mark in your chemistry GCSE, every single mark counts. Okay. Hopefully you've got it correct. It's the middle one, of course, it is C2H4. You're just counting the carbons and you're just counting the hydrogens. Okay, so really, really well done. If you didn't understand anything, I'd strongly recommend that you go back through the video, maybe watch it a couple of times and spend a little bit of extra time on those activities. It would probably really help when it comes to revision. Okay, thank you very much for listening.